What if a single breakthrough could solve problems that today's most powerful supercomputers can't even begin to touch? What if humanity's toughest challenges, climate change, disease, hunger, and energy, could be unraveled not in decades but in moments? That's not science fiction anymore. It's the promise of quantum computing, a technology so advanced it's often described as the biggest leap in human innovation since the invention of electricity. While most computers crunch data in simple bits, ones or zeros, quantum computers use qubits, which can exist in multiple states at once. It's like being able to explore every possible solution to a problem simultaneously, instead of one by one. And that's exactly why scientists believe quantum computing could change everything. The quantum revolution begins. To understand why quantum computing matters, imagine trying to find the fastest route through a maze with millions of paths. A classical computer tests them one at a time. It's efficient but limited. A quantum computer, on the other hand, can explore all paths at once, thanks to quantum principles like superposition and entanglement. This power doesn't just mean speed, it means tackling complex, real-world problems that are currently unsolvable. From optimizing global energy systems to creating unbreakable encryption, quantum computing represents a new kind of intelligence, one that could redefine human progress. But where will this revolution matter most? Let's break down how quantum computers could literally reshape our world. 1. Curing diseases and revolutionizing medicine. Drug discovery is one of the most time-consuming, expensive, and uncertain processes in modern science. Testing billions of molecular combinations to find one that actually works can take years. But quantum computing changes that equation entirely. Instead of simulating chemical reactions through limited approximations, quantum computers can model them at the atomic level, calculating the exact behavior of molecules and proteins in real time. This means faster drug development, cheaper clinical trials, and far more targeted treatments. Imagine quantum algorithms predicting how a new compound binds with cancer cells before a single lab test is done. Pharmaceutical companies could design cures for diseases like Alzheimer's, Parkinson's, or even rare genetic disorders, faster than ever imagined. In the future, we might see personalized medicine powered by quantum simulations that analyze your DNA and create a treatment tailored specifically to your molecular structure. It's healthcare beyond precision. It's healthcare powered by quantum reality. 2. Tackling climate change with quantum power. The planet's climate systems are some of the most complex structures known to science. Billions of variables, temperature, ocean currents, atmospheric gases, interact in ways that defy traditional computation. That's why accurate long-term climate modeling has always been so difficult. Quantum computers, however, could process massive data sets with unparalleled accuracy, simulating entire climate systems down to the smallest details. They could predict how carbon levels will impact specific ecosystems, model the effects of geoengineering, or optimize renewable energy grids in real time. Even more exciting, quantum algorithms could design new carbon capture materials, molecules engineered to pull greenhouse gases directly from the air. These materials are difficult to create using classical simulations, but quantum chemistry could make their discovery faster and more precise. In short, quantum computing might be the tool that finally lets us understand, predict, and counteract climate change on a scale never before possible. 3. Solving the global energy crisis. Energy is at the core of every economy and every crisis. From power grids to battery storage, efficiency is the difference between abundance and shortage. Classical computers are great at optimization, but when it comes to the scale of global energy systems, the complexity becomes overwhelming. Quantum computing could optimize power distribution networks instantly, balancing supply and demand with near-perfect accuracy. It could simulate nuclear fusion reactions, accelerating the search for clean, limitless energy sources. Battery technology is another field ready for a quantum revolution. Current lithium-ion batteries are reaching their limits, but quantum modeling could identify new materials for super-efficient, long-lasting batteries, transforming electric vehicles, renewable storage, and portable devices. Quantum energy simulations could even unlock molecular-level catalysts that make hydrogen production more efficient, paving the way for a true green hydrogen economy. 4. Reinventing cybersecurity and data privacy. Quantum computing doesn't just solve problems, it also creates new ones, especially for cybersecurity. The same quantum power that can decrypt current encryption methods in seconds poses an existential risk to global data systems. But paradoxically, quantum technology is also the solution. Enter quantum cryptography, a new security system that relies on the laws of physics instead of mathematical complexity. Using quantum key distribution, information can be transmitted in such a way that any attempt to intercept it immediately alters the data, making hacking virtually impossible. Governments, banks, and corporations are already exploring quantum-safe encryption, preparing for the day when classical security will no longer be enough. The next digital era will likely be guarded not by stronger firewalls, but by the fabric of quantum mechanics itself. 5. Revolutionizing transportation and logistics. Think about the sheer complexity of global transportation. Planes, ships, trucks, and trains all moving goods across the world. Optimizing routes, fuel use, and delivery times involves analyzing countless factors, something even supercomputers struggle to do efficiently. Quantum computing could process these variables instantly, finding the most efficient paths through billions of possibilities. Airlines could cut emissions by optimizing flight routes dynamically. Shipping companies could save millions in fuel. Autonomous vehicles could communicate with each other through quantum-enhanced systems, reducing traffic and improving safety. The result? A logistics network that functions almost like a living organism, adapting, learning, and evolving in real time. 6. Supercharging artificial intelligence. AI is already transforming industries, but it's limited by how fast classical computers can process data. Quantum computing could take AI to the next level, creating quantum neural networks capable of learning and reasoning at unprecedented speeds. With quantum power, AI models could analyze exponentially larger datasets, find patterns humans can't detect, and make decisions in real time. From financial forecasting to healthcare diagnostics, the combination of AI and quantum computing could unlock levels of intelligence that redefine automation and discovery. Imagine AI systems capable of understanding complex human emotions, simulating biological systems, or even predicting social and economic outcomes with astonishing accuracy. The merging of quantum and AI could make artificial intelligence feel a lot more human. 7. Strengthening financial systems and economies. Global finance runs on data, massive, fast-moving, unpredictable data. Markets shift by the second, and even the best predictive algorithms can only do so much. Quantum computing could change that, giving analysts tools to simulate entire markets under countless conditions. Banks could use quantum models to manage risk more effectively, prevent crashes, and optimize investment portfolios. Governments could use it to forecast economic trends and plan policy decisions with far greater precision. Even fraud detection could be revolutionized, as quantum-powered algorithms detect subtle anomalies invisible to classical systems. In short, the financial world could become faster, safer, and more efficient. 8. Accelerating space exploration. Beyond Earth, quantum computing could help humanity explore new frontiers. Space missions require solving millions of variables: fuel efficiency, trajectory, communication delays, and system reliability. Quantum algorithms could handle these calculations in moments, enabling faster mission planning and real-time corrections during flight. They could also process data from distant planets or telescopes far faster, helping scientists identify new celestial bodies or signs of life. And as space becomes more commercialized, quantum optimization will be essential for navigation, communication, and resource management across vast distances. A quantum future within reach. It's tempting to think of quantum computing as a distant dream, but the truth is, it's already here, just in its infancy. Tech companies, research labs, and governments are investing billions to make quantum processors stable, scalable, and accessible. We're still years away from universal quantum computers that can solve any problem instantly, but the specialized machines we already have are proving their worth, solving optimization problems, improving AI algorithms, and advancing materials science faster than expected. So here's the big question: what problem would you want a quantum computer to solve first? Climate change, disease, poverty? The future isn't waiting, it's being built one qubit at a time. If this glimpse into the quantum revolution opened your eyes, make sure to like, subscribe, and turn on notifications.